Python does not run your source code directly. It converts it into the bytecode, and let me show you the exact bytecode for this tiny program. So here is my code, but I am storing it as a string. Now instead of executing it directly, I use a built-in module called dis. Dis means December. It shows you the bytecode instructions that CPython actually runs. So I call dis.date source code. Let's run it. And it prints a list of instructions like this. Now to understand this output, you only need a one idea. CPython is a stack based. Python keeps pushing values onto it and popping values off it. Now let's walk through the bytecode. First you see resume. You can think of this as okay, start executing. Now for a equal to 10, you see two instructions. Load const 10, store name a. This is Python saying push 10 onto the stack and then pop it and store it in a. So the stack briefly becomes 10. Then it becomes empty again after the store. Next, b equal to 20 is the exact same pattern. Load const 20, store name b, push 20, store it into b, stack becomes empty again. Now the interesting one, c equal to a plus b. You will see load name a, load name b, binary op plus store name c. Here is what that means in simple language. Load name a pushes the value of a onto the stack. So now the stack is 10. Load name b pushes the value of b. So now it is 10 and 20. Then binary op pops both values, adds them together and push the result back in the stack. So now the stack becomes 30. And finally, store name c pops 30 and save it into c. Stack is empty again. So at this point, c equal to 30. Now the last line, print c. You will see this sequence, load name print, push null, load name c, call 1, pop top, return const none. Let's go step by step. Load name print pushes the print function onto the stack. Then push null pushes an empty placeholder. This is just there so CPython can keep the same call layout for both normal functions calls and method calls. In our cases, it is a normal function calls, so it uses null as the placeholder. Then load name c pushes the 30 onto the stack. Now call 1 means call the function with one argument, so it calls print 30. And here is something people miss. Print function returns none. So after the call, that none is sitting on the stack, but we are not using that return value. So Python throws it away using the pop top. That is basically remove the top value, we do not need it. And finally, return const none ends execution. This code is running at the top level, so when it finishes, the final result of the executing the whole block is none. So the block number 30 is not returned, it is printed as an output. Now quick questions. Why does CPython even gives us the dis module? 3 reasons. First, learning. You can literally see what Python is doing under the hood. Second, performance and profiling. You can compare two pieces of code and see which one creates fewer options. Third, debugging. When code behaves in a surprising way, bytecode show the real steps CPython is executing. That's it. Source code becomes bytecode and CPython runs it using a stack. If you want, in the next video, I can show you two Python snippets that look almost the same but produce different bytecode, and the performance difference suddenly makes sense. If you like my video, just subscribe and comment if you have any doubt. That's it for today. Thanks.